Everybody, this is Mr. Folly, and welcome to Podcast 3.1. We're finally going to get into what we've all been dying for, moles. We'll do some percent composition and empirical formulas as well. So let's happen to it. All right, mole. A mole is the fundamental definition of an amount. So definition or unit. So if someone says, what's the amount of something, you should give the answer in moles. And there's 6.02 times 10 to the 23rd particles in a mole. And this is the grouping of particles. Remember, because atoms and molecules are so small, you need to have a large number in order to have that amount. So basically, whenever you have a grouping of something, like a dozen eggs will fit in your hand, or a gross of bottle rockets will fit in your hand, a mole of particles will fit in your hand. It's about a handful. Okay. On your periodic table, there's a thing called a gram atomic mass. Okay. So if you look at sodium in your periodic table, number 11, this is the gram atomic mass. So that is the average mass of a mole of sodium. And we learned before that there's different sodiums out there. So some of them are sodium 23, and there's probably a sodium 22, and maybe even a sodium 21. And those are the mass of the individuals, but their weighted average would be 22. So let's figure out how to do this. All right. So what is the mass of 1.76 moles of magnesium cyanide? 1.76 moles of magnesium cyanide. Magnesium is Mg. Cyanide is Cn. Remember, magnesium from the periodic table is +2. And cyanide we memorized to be -1. So to make these balance, it takes two of these negatives, two negative ones to balance the +2. All right. So we want to convert this into mass. So I'm going to put a mole on the bottom of magnesium cyanide. And I'm going to go into grams of magnesium cyanide. And I say little g stands for grams, and little g stands for go to the periodic table. So the periodic table, magnesium is 24.31. Carbon is 12.01 times 2. And nitrogen is 14.01 times 2. And the times 2, this 2 means I have 2 carbons and 2 nitrogens. So when I add all that up, 24.31 plus quantity 12.01 to plus sorry, it shouldn't be so hard. It's quite easy. I get 76.35. So 76.35 is the mass of 1 mole. So if you set it up like this, then all you're going to do is multiply that number times 1.76. So that's 134.4 grams. Okay, or to 3 sig figs, 134 grams. Right? How many atoms total are there in barium hydroxide? It's in 2.5 grams per atom. 2.50 grams of barium hydroxide. And what I want is atoms. So barium hydroxide has 1 barium, and it has 2 oxygens, it has 2 hydrogens. So once I get that into moles, I'm going to multiply it. I'm going to use those numbers for that. So here we go. First, we got to go from grams into moles. Yeah. Grams of barium hydroxide, come on. And 1 mole of barium hydroxide. The barium is, we got to do it. I'm going to estimate barium because I don't have a periodic table. So barium is 140 point something. I'll go to my ever-present phone. This will work. Okay. Okay, so barium is 137.27. Oxygen is 16 and hydrogen is 1.01. So when I add that together, sorry about that, 137.27 plus 32 plus 2.2, 171.29, and 1 mole of barium hydroxide. That's weird. Okay, so now that I'm in moles, I want to leave moles, 1 mole of barium hydroxide, and go into atoms. And there are molecules for 6.02 times 10 to the 23rd molecules of barium hydroxide. Okay. And then 1 molecule of barium hydroxide, and really you can call it a formula unit because it's an ionic compound, has 2, 4, 5 atoms. So again, so what I did was I started with my mass, converted it into moles. That is a count of particles. And then I went from moles into molecules, and then multiply it times 5 because I have 1 barium, 2 oxygens, 2 hydrogens. So let's run that through a calculator. 2.5 divided by answer times 6.02 E23 times 5, 2 times 5, and I get 4.39 E22 atoms. All right. Percent composition, empirical formulas. Percent composition, I hope that doesn't show up on all these slides. Percent by mass of each element in a compound. So percent is always part over total times 100%. Okay. It's percent by mass of an element in a compound. What is the percent nitrogen and ammonia? Ammonia is NH3. So if I want to find the percent nitrogen, I'm going to go to the periodic table because I'm going to do this with mass. In my periodic table, nitrogen back here, is 14.01 over NH3 is nitrogen plus 3 hydrogens, which would be 17.04. So I have N over NH3. Okay. So 14.01 divided by 17.04 is 82.2%. Actually, it'd be 0.822. But remember to change it to percent. You multiply it by 100%. All right, empirical formula. The empirical formula is the simplest formula for a compound. Subscripts are all relatively prime. So there's some weird things out there, like there are some things that are like C12H22O6. So if you have something like that, that's not an empirical formula because it can be simplified by dividing them all by 2, and you get C6H11O3, and that would be a simplified formula. Okay, this would be the exact formula, which would be called the molecular formula, and then this is the empirical formula. So let's show you how to do that. To find the empirical formula from data, so they've given a percentage or masses, and you're going to convert them to moles as always. Reduce them by dividing by the smallest number. Multiply to get a whole number. The answer for 3 is the subscript to the formula. Okay. This is better off just doing it. Okay. Empirical formula for a compound that is 24.3% carbon. So I'm going to start with 24.3. I'm going to assume 100 grams sample. 24.3 grams of carbon. 4.1 grams of wine. And then, that's 4.1 grams of hydrogen. And the rest chlorine. So let's figure out what that would be. 100 minus 24.3 minus 4.1, 71.6. Now the way I got this was there's 100% total. So I'm going to take away the other 2 parts, and what's left over is going to be chlorine. So now what I'm going to do is I want to get these into moles. So I talked about how we always go through moles. I'm going to get this one into moles. Get into moles. get this one into moles. And I just want to mention for a minute that these aren't diatomic here. Okay, so I know there's diatomic elements, but we want to know the exact number of C's, H's, and Cl's, not pairing them up. So let's do that. 24.3. 24.3 divided by 12.01 is 2.02. 4.1 divided by 1.01 is 4.05. 71.6 divided by 35.45 is 2.01. And then what you do is, if I was an idiot, I would say, oh, it's C 2.02, H 4.06, Cl 2.01. But they need to be whole numbers. So what we're going to do is divide by the smallest number. Divided by 2.0197, divided by 2.0197, divided by 2.0197. That's dividing by itself, that's 1. That's dividing by close enough to itself, that's 1. And 4.0594 divided by 2.0197 is 2.009, that's 2. So what that means is I have CH, so I have I have 1 carbon, this number was 1. This number was 2, so 2 H's, and this number was 1, 1 Cl. I don't know if those numbers are running away from me. Molecular formula. The exact formula of a molecule given the types of atoms and the number of each type. So see how this was reduced, perhaps? The CH2Cl, a molecular formula might be something like C6H12Cl6, where they're all times 6. To find the molecular formula, do your empirical formula, and then take your molecular mass and divide it by the empirical mass. So how do you get that? Go to the periodic table. How do we get this? So let's take a look. The empirical formula found before had a molecular mass of 199. What is the molecular formula? So it's 199 divided by, what do we have before? CH2Cl? Yeah, CH2Cl, although my numbers are gone. So CH2Cl is carbon, which is 12.01 plus 2.02, with 2 hydrogens plus 35.45. So 12.01 plus 2.02 plus 35.45 is 49.48. And what I get there is 4.02, which is roughly equal to 4. So I'm going to multiply that by 4. C4H8Cl. Okay. So what I'm really doing when I do that is I want to know how many CH2Cls fit in here. Okay. So if I want to know how many fit into it, that's literally what dividing is, right? How many times can I divide it by CH2Cl? And instead of using CH2Cl, I'll use the mass on it. Good. So review, always go through moles, always go through moles. Empirical formula are moles. Molecular formula moles. So what that means, CH2Cl. This is 1 mole of carbon, 2 moles of hydrogen, 1 mole of chlorine. That's it. And we're going to find the formula of the hydrate. Hey, we kind of did that already. All right. Toodles.